Hello everyone, for the 10th part of our project. 10, yes, this is a milestone, yoo-hoo, let's celebrate. I'm gonna start, as you can see, with a bit of technical knowledge. My idea here is to give you a global overview of what is possible, but then from my point of view, there is nothing better than the experience of doing things on your own so that you can really understand how things works. I think it's better for you to try and to train your eye to know what's looking good or not. So I'm gonna start with this scene. I have at the top two images and then below they are mixed together using blend modes from the mix RGB node. At the top, you've already seen it, the mix mode, which takes both images and mix them with a factor going from 0 to 1, just like that. See that as being something that controls the opacity of each images, and so at factor 0, the opacity of the image on the left is 100%, and the other one is of course the opposite, 0%. So that's why at the middle, both the images are at 50% and on top of each other. This doesn't change if you modify the order of the inputs. Then you've got the add mode. Add, only keep the white areas from both images. You see that the left images doesn't change and the white areas from the second images are added to the image. Again, the order of the input doesn't change anything. Then you've got the darken mix mode. We've already seen that as well. This adds to the first image the black areas of the second image. This is the result we're gonna have. It has removed here on the left the dark areas from the second image. The order of the input will have a consequence on the result, but because those images are symmetrical, the result is similar. Then we've got the lighten mode. Lighten will only modify pixels from the first image only if they are darker than the ones from the second image. So this area here from the first image is black, so it is darker than what we have here on the second image, which is kinda white and gray. That's why it's adding this area. Then we've got overlay. Overlay only modifies gray areas from the first image. If you look at it, this where there is this black line, it is gray around. So if I increase the factor of the mixed RGB node set in overlay mode, you can see that the grays area are replaced by what we can see in the second image. Then we've got subtract. Subtract removes from the first image the areas that are white in the second image, making them black. The result is a black area, like this. And then you've got linear light. Linear light replace what is gray in the first image and also adds what is white in the second image. And the factor controls how much gray is replaced from the first image. Look at if I increase it, this gray area becomes blacker and blacker, so what we see in the second image, and from the second image, it is adding first what is white, meaning the top of the sphere and the bottom of the sphere, and then little by little, adding more up to what is gray. This is why it doesn't add more this area, because it is gray, so it doesn't modify it. And this, what we see here, the black area, comes from the first image. Okay? So that was the mix mode. Now we're gonna have a look at the different texture nodes. I have laid them down here. If you look at the list from the texture node, you will have more than what is displayed on the left, but the other ones are not really used for materials, they are used for something else that we might see later on. So, just to give you an overview of what it looks like, we've got the bricks, it's self-explanatory, checker, we've got a gradient, the magic texture, I usually don't use it a lot, but I'm sure you can find a use for it. The Musgrave texture, then you've got the noise, the Voronoi, the wave texture that makes lines, and then you've got something called white noise. You barely see it, but it is almost like a miniature noise with every single point of this image having a different color. So that was quick, but this gives you an overview, as I said before, of the procedural textures. Next, of course, I have a few more things to show you. Next are the coordinates. Remember, when we have a texture coordinate node, there is several outputs, and so far we've used the object outputs. I'm only gonna show you 3 of them today. The generated output, which is used by this cube, the object output, which is used by this cube, and first I'm gonna start with the UVs, which are a way to assign coordinates manually. If we look at this plane, it is using the UV output on an image, which I've called world map, because I see this as a kind of map, meaning that if we had this map, we can see that using a map in real life, we can have coordinates. Like when we say 30 degree longitude and 20 degrees latitude, these kind of things. And in UV language, I think, but I'm not sure that this is to replace the X and Y axis, but they call it UV so that we don't mix the two. So these are the U's, and these are the V's, X and Y. And this goes from 0 to 1 on both axes, meaning I divided it into 5 different parts so that it's not too complicated. So you've got 02, 04, 06, and let's say 08. The same on this side as well. So now, when I think about coordinates, this means if I have something in here, its coordinate will be 02 on the U axis and 06 on the V axis. Okay? Now, if we look at this plane, what I'm gonna do is select one vertex from it and move it in this UV space into the coordinate that we've set. Okay? I'm gonna take the second one here and move it to a coordinate beside. Then the third one here on the bottom left on this coordinate. So 02 on the U axis, but 04 on the V axis. And then the last one will be here. And what we can see, if it's straight enough, let's say, like that, is that now, on this map, we have set up the coordinates of this plane, and if you look closely, you will see that it's displaying exactly this square from the map. Okay? That is why we talked about texture coordinate. If I now duplicate this plane, I can give it another coordinate, moving it somewhere else, like this, or maybe this will be a bit clearer. Now, you can see that it is displaying exactly what is on this image using the coordinates from each of its vertices here, which is, for example, 04 on the U axis and 2, 4, 6, 8 on the V axis, and so on for each of the vertices from your model, which at the end will determine what part of this map is displayed where on your model. These are the UVs, and this, what we see here, are called a UV map. Okay? Now, we are mostly working with this type of coordinates, generate or objects, and I'm gonna show you what's the difference between the two. Generated coordinates are generated based on what we call a bounding box, which is a box around your object. Whenever you modify your object, this is a sphere taken as an example, you can see that the bounding box is modified with the object. I told you that UV space only goes from 0 to 1, okay? And this is what we have on that bounding box, meaning if I scale this object as well on the y-axis, the texture is stretched, because we consider this to have a value of, let's say, 0, and this to have a value of 1 all the time. The texture is only stretched with the object. I'm using the y-axis, but it's the same on every axis. Okay? The difference with this object, if I scale it on the y-axis, you can see that this is stretched as well. So where is the difference? The difference lies in the fact that this bounding box will always be the same, meaning going from 0 to 1. If I look at the scale of my object and I reset it using Ctrl A to open this menu and choose scale, it is 111, but this hasn't modified the way the texture is displayed on the object. Whereas, if I do it on this object, you can see that the texture has reverted back to the way it looks, meaning that for this texture, the 0 to 1 value goes like that, but for this type of coordinates, because I used the word texture earlier, but this is really coordinate that I should say, the 0 to 1 axis is here, and then the coordinate is repeated, meaning that we have here a 0 to 1 as well, and here as well a 0 to 1, let's say, like this. Okay? So, using the object coordinates, we'll make sure that no matter the scale of your object, or I should say the size of your object, your texture will always look the same. So I think that's it for for the texture coordinates. Let's move on. This is the last thing I want to talk to you about. We've talked about something called normals before, which is supposed to be a vector which direction is perpendicular to the surface of a polygon, okay, like that. And to balance sometimes the need for performances and the need for details, we use some kind of maps that were modifying the look of the object, but not the geometry of it. What I have here is a simple plane, and I have applied what is called a bump map. A bump map was a black and white image, and if you look at this, consider the black part to be something like an extrusion inside. If we look at the side of this object, what this is supposed to do is having something flat on the white area, a bump down in the black area, and then something like that. Okay? If you look at this object, you can see it's very subtle, but you can almost see it. There is a line here, which is darkened, which represents the gap down, and there is a line here, brighter, that represents this angle here. Okay? If I move this light around, you can see maybe a bit better here the different edges. And this is just a trick because the plane is still flat, but this allowed us to add details to a geometry without having the set geometry. Nowadays we use what we call normal maps. They are represented like that. So before we had black and white images. Remember, black and white can be assimilated to value going from 0 to 1. Okay? And this, with the normal map, you have now 3 values, as if it was a color. You have a 0 to 1 value, another one, 0 to 1 value, and another one, 0 to 1 value. This means that compared to a bump map where you only have a map that is about the elevation of the geometry, this is about the orientation of individual faces. So you can have something much more complex than what you have with a bump map, which of course this is not the nicest normal map, but I think you get the idea. You have the impression that this is not just something going up or down like that, but that you have something like that, like this, they can have a lot of different orientations and in all the 3 axes, X, Y, and Z. And the last thing I want to talk about is called a displacement map. This is also a black and white image, and what it does is that it's moving the geometry based on an image. If you only got a simple geometry like that, this is a simple plane, this won't work. So that's a trade-off. You don't have to model the details that you want, but you need geometry for the effect to be visible. I have a subdivision surface modifier on this plane, and if I increase the level of subdivisions, we get a lot of details, and these are driven by this map. That is what is called displacement. Okay? So, I think I'm done. That was all the things I wanted to talk to you about today. And now, let's move on to a demo. So now, I'm gonna show you how I create a wood material. I'm not using the frames like before, but from now, I hope you are able to create your own node structure without having to rely on the frames being here. I'm still using the same kind of thoughts, but without the frames. Okay, so first, I'm gonna add a texture coordinate node, and if you remember from what I showed earlier, the texture that looks more like it could be used as a wood texture is the wave texture. I'm gonna connect the coordinates, and you can already see it could be close enough. I'm gonna change a bit the parameters, and I want first this to be as clean as possible. Okay, maybe just like that. What I'm gonna do now, instead of using bands, is using rings, and you can see it could already be used as a wood. That's something new I'm gonna show you. Remember, a vector is 3 values ranging from 0 to 1 for each axis, and therefore it can be changed. A texture is a color map on your object, but these colors can be assimilated to numbers ranging from 0 in the blacks to 1 in the whites, meaning that if I add now, let's say, a noise texture and I insert it in between the object coordinates and the wave texture, this noise texture will affect the texture coordinates. Let's have a look at the result, and you can see that both mixed together we have something different. Now I'm gonna change the settings of this noise texture, okay, so that it still stays like a clean wood, and this is what I'm gonna start from. Let's add a color ramp so that we can define colors for our wood. And what I want is to have these lines not black, but maybe some kind of dark brown, and this white. First, I'm gonna use this sample tool to make them the same brown as the lines, and then I'm just gonna make them slightly brighter. And this can already be considered as being a wood material. Of course, what I will do now is adding layers to this. I can start by selecting these two nodes and using on my keyboard Ctrl Shift and D to duplicate but still keep the existing connections, meaning the object coordinate inputs. If I look at this, what I like now is having details, okay, something like that. And now I'm gonna move this aside. I'm gonna use another color ramp and then modify these values. Maybe I can start by sampling this from here and then make it maybe a bit brighter. Let's say like that. Okay. And now what I can do is mix both these colors. I can add a mix RGB node manually or use on my keyboard the Ctrl and Shift key and then right click drag to have a green line between these two nodes, and when I release my mouse button it will add the node automatically. Pressing H on your keyboard or clicking on this little arrow here, fold or unfold the node. Now what I'd like to do is mixing those two colors, but again maybe the mix mode is not the right thing to use. Based on what we've seen before, what would be a good way to mix these two? I'm gonna choose lighten. And what we see here is that the bright areas from the second texture are combined with what we had before, and with the added details here. Okay? So now if we look at the result here, I think it's even more convincing. Okay? And lastly, I like having at least 3 layers of details. I'm gonna add another one with this selected Ctrl-Shift-D, duplicate with the existing connections, and this time I'm gonna reduce the scale a lot and add distortions like this, maybe even smaller, like that. And what I can do is adding a color ramp so that I can have the least amount of details I want, something like this. I can make this brownish, like I did before, even brighter. Okay, and the other one can be made dark. That's it. Okay, and now let's mix it with what we already have, meaning this. I will move this on the side, Ctrl Shift, right click, drag like that, H to reveal this node, and let's select the screen blend mode. Let's see how it goes to this node. You might be able to see now the small little lines here. Okay, I will make them slightly visible, barely visible. Okay, so now let's have a look at the results. And of course, like for the metal, I'm now gonna work on the roughness. Let's start with a value. Okay, value. Let's connect it here to the roughness, and of course it is at 0, so it's highly reflective. Let's make it a bit less, maybe something like that. And because we need a mix, I'm gonna duplicate that, have a look at it, change its settings to something less reflective, like that. Okay, and now what I want to do is to mix both these colors based on the output we have here. So I'm gonna add a mix RGB node, and then use this, add a factor, and if we have a look at the results, this is what we get. The dark areas are a bit less reflective than the bright areas. Okay? Next, of course, I want to use this output to mix a third value. So let's do that. And because this will come from the top, I'm gonna do this like this, let's say. Mix. Okay. And then, because this is not black and white, what I can do is have another one and modify the value of the second slider, this one, to a white. Okay, this is white now, and now use it as a mix. Let's see what we get. At the moment I haven't changed the value of this compared to what we have here, and because this is under little scratches, I want them even less reflective, so I've given them a value very close to 1. Okay? And if we want it, we could stop here, like we did for the metal, but remember earlier I showed you something which was about normals. So to use it, it's this input of our principal BSDF shader. Okay? To use it, we always need a vector. The best I like to use is the bump node. I can connect the normal output to the normal input of the shader. And then, as an input, I'm gonna use what we have here, meaning the small scratches. I'm gonna plug it into the 8 input, and then wait for the results. There you go. You have to understand that dark areas are going in and the whites are going out. So if you use directly that, this is not what we want. We want this to be the blacks. So we need another one of this. Okay? And we need to reverse the blacks and the whites. I plug it now, this to the 8, and have a look at how it looks. Okay, this is better. This looks like it's going inside. For the settings of this bump map, distance here is the fake distance between the surface and the maximum height of the bump. So we don't want something very big. And the strength here is how much you see the effect. And again, I don't want that to be too much. Now, remember, we modified a vector with another vector in the middle. So, what we can do here is duplicate this bump node and add it right after the first one. Then we can use something else to drive its values. I'm gonna use the output of this node in the 8 again, and let's have a look at the results. This is what we got. I'm gonna make it a bit less strong, okay, and see, now we've got our wood material. Okay, that was quite a long video, but I hope you got a lot of useful tips from it. I'll see you in the next part. Enjoy creating materials again. Have fun. Bye.